Imagine holding the power of the sun in the palm of your hand, energy so vast and clean that it could power humanity for millions of years. It's not a dream. It's the future that plasma physics and fusion energy promise to unlock. Welcome to the Learning Studio, and in today's episode from our physics playlist, we'll explore the blazing heart of the universe, where matter becomes plasma, and energy generation enters its most advanced frontier. You can watch the entire physics playlist by clicking the link below in the description. This topic belongs to our section Matter, Materials, and the Rise of Technology, where we uncover how the most extreme states of matter are leading us toward a sustainable, energy-rich future. The fourth state of matter, what is plasma? We all know the three classical states of matter, solid, liquid, and gas. But there's a fourth, one that dominates more than 99% of the visible universe. That's plasma, a superheated gas where atoms lose their electrons, creating a sea of charged particles. Plasma glows in the night sky as auroras, burns in lightning bolts, and fuels every star in existence. It's the state where matter and energy merge into something dynamic, beautiful, and immensely powerful. Plasma behaves unlike anything else. It conducts electricity, generates magnetic fields, and interacts with light in astonishing ways. Studying it isn't just about understanding stars, it's about harnessing their power. Fusion, the power of the stars. In the cores of stars, gravity crushes hydrogen atoms together until they merge, a process called nuclear fusion. When two light nuclei, like hydrogen, fuse to form a heavier one, like helium, an enormous amount of energy is released. Unlike fission, which splits atoms apart and produces radioactive waste, fusion joins them together, producing almost no pollution and nearly limitless energy. To recreate fusion on Earth, we need to do something extraordinary: heat hydrogen gas to over 100 million degrees Celsius, turning it into plasma, the same fiery state as inside the sun. That's the goal of plasma physics, understanding how to control, confine, and sustain plasma long enough to extract its energy safely and efficiently. How we're building a star on Earth. The most advanced attempt to achieve this is the ITER project in France, an international collaboration between over 30 countries. ITER, International Thermonuclear Experimental Reactor, is designed to be the world's largest fusion reactor, using powerful magnetic fields to contain superhot plasma inside a donut-shaped chamber called a tokamak. These magnetic cages keep the plasma suspended in midair, preventing it from touching the reactor walls, a delicate dance of physics, temperature, and control. At the same time, scientists are also exploring laser-induced fusion, where ultra-powerful lasers compress a tiny fuel pellet, mimicking the extreme pressures of a star. Both approaches share a single goal: sustainable, self-sustaining fusion, the holy grail of clean energy. The role of AI and advanced physics. Fusion energy isn't just about heat and magnets, it's about control. The plasma inside a reactor is chaotic, unstable, and unpredictable. That's where artificial intelligence and machine learning come in. AI models now help physicists monitor plasma behavior in real time, predict instabilities before they occur, and optimize magnetic confinement systems. They simulate complex plasma interactions that would take traditional computers centuries to calculate. This fusion of physics and computation is accelerating breakthroughs, bringing the dream of a working fusion reactor closer than ever. Why fusion energy matters for the future. If successful, fusion could change the world forever. 1 kilogram of fusion fuel could generate as much energy as 10 million kilograms of coal, without greenhouse gases. It uses deuterium and tritium, found in water, and lithium, elements abundant on Earth. And it produces almost no long-term radioactive waste. Fusion could power entire cities, spacecraft, and even AI-driven industries with virtually infinite clean energy. It could end the global energy crisis and help reverse the effects of climate change, not through limitation, but through innovation. This is why governments, private companies, and research institutions around the world are racing toward the same goal, to light our world with the power of the stars. The plasma future. From the auroras in our sky to the fusion reactors on Earth, plasma physics connects cosmic beauty with practical brilliance. It's a field that combines quantum mechanics, electromagnetism, thermodynamics, and engineering, all working together to unlock a sustainable future. And as AI continues to model, design, and optimize these systems, plasma physics will become one of the key pillars of the next scientific and technological revolution. This is the Learning Studio, and this was our episode on plasma physics and fusion energy. If you're fascinated by how the same forces that power the sun could one day power our world, make sure to subscribe, like, and check out our physics playlist linked below. In our next episode, we'll explore condensed matter physics and emergent phenomena, where complexity itself becomes a new form of order in the universe. Because in physics, every star reminds us that the ultimate source of energy isn't in space, it's in our understanding.